So in this video, I'll be going through the November 2021 paper 2 higher. Let's make a start. The first question is asking to write down the inequality that's shown there. And since the circle is not filled in, we're going to write x, which comes from there, is greater than -1. If the circle was filled in, it would be greater than or equal to -1. So on the number line below, show this inequality. Since this is less than or equal to, we're going to fill that in. This one will not be filled in, so we're just going to circle that. And we're going to connect them two together with a line. Moving on to question 2, find the highest common factor of 60 and 84. So 60 and 84, so that's 2, 32, 15, 3 and 5. That is 2 and 42, 2 and 21, 3 and 7, 60, 84. That's 2 times 2 times 3 times 5. Notice I am writing them in order from smallest to biggest. Now we need to find matching pairs. So matching pairs here would be, let's use a bigger one, that and that, that and that, that and that. So in this case, that becomes, you can use a calculator as a 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. So the highest common factor here is 12. And for B, it's asking for the lowest common multiple of 24 and 30. We can go in a similar manner, draw the factor tree out. So that's going to be 2 and 12, 2 and 6, 2 and 3. That's going to be 4 and 10, 2 and 2, 5 and 2. So for 24 and 40, so for 24, we have 2 times 2 times 2 times 3. For 40, we have 2 times 2 times 2 times 5. Again, we're going to go for matching pairs, so that's going to be that, that, that. However, one difference here is we're then going to multiply what's left over, so that's 2 times 2 times 2, so that comes from there, that comes from there, that comes from there, then 5 times 3. Now, if you type that into your calculator, you'll get 120. So here we've been given a graph. It's saying work out Sam's speed in kilometers per hour for the first 15 minutes. So straight away, it's saying kilometers per hour. We want to convert the 15 minutes to hours. We can divide that by 60. And that gives us 0.25 hours. And now we know the formula is speed is equal to distance over time. It's asking for speed, so that's going to be the distance, which is 20. So that's that bit there in the first 15 minutes. Divide that by 0.25 and you get 80 kilometers per hour. So at 10:15, he stops for 10 minutes. So the 10:15 is right here. He stops for 10 minutes. So for the next 10 minutes, it's going to be a straight line. So he stopped. And then he drives for 20 minutes at the speed of 75 kilometers per hour. So again, we've got a similar situation there. We've got 20 minutes and then we've got the speed in kilometers per hour. So we want to use the same unit, so we can convert the 20 minutes to hours. So that's going to be 20 over 60 in terms of hours, converting from 20 minutes to hours. And again, we have speed is equal to distance over time. We have the speed at 75 is equal to distance over time, which is 20 over 60. So we can do 75 times 20 over 60, and that gives us the distance as 25 kilometers. So we know she continues on from this point for another 20 minutes. So that's going to end up here after 20 minutes. And we know she started here and she drove for a further 25 kilometers. So 25 will end up here. So if you look here, after 20 minutes, we're going to plot this point right there. So for the next one, just be careful typing this into your calculator, because for negatives, you do want to use brackets. So that'll be -1 squared minus 2 minus 1 plus 2. Type that into your calculator and do that for all the values, and you end up with 5, 1, 2, and 10. And the next question is asking us to plot this. So -2 and 10. So that's going to be that one there. -1 and 5. 0 and 2. 1 and 1. 2 and 2. 3 and 5. 4 and 10. And then a smooth line through them all. So it's saying use your graph to find estimates for x squared minus 2x plus 2 is equal to 4. So if you look at the equation that we've been given up here, they're now saying that this is 4. So y is 4. So if you go over to the graph, y is 4 right there. We're going to draw a line across until it touches the graph. And draw a line across here until it touches the graph. And we're going to come down. And we're going to do the same here. And we're going to read off that value. So in this case, that is going to be 2.75. Well, it should be a bit less than that. I think I've drawn the line a little bit too far. So I'm going to go with 2.7. And you don't want to write these as coordinates because they're two values. So it's 2.7. And on the left-hand side, we have 0.7. So it's roughly there. And that's minus 0.79. Moving on to question 5, you have a right angle triangle. The same right angle triangle, this bit is key here. So the shape below is made of two of these. Work out the perimeter. So to work out the perimeter, you just add all the sides together. So if I just get my red pen here, essentially to work out the perimeter, we are adding all of this together. The only thing we don't know here is this side and that bit there. So we need to figure out what this and this is, and we have everything else. So hopefully you've spotted that we can use Pythagoras theorem here to work out what this is. If you call that c, you know Pythagoras theorem is normally a squared plus b squared is equal to c squared. So in this case, it'll be 8 squared plus 10 squared is equal to c squared. That's 164 is equal to c squared, and you end up with c as 12.80624847. And now we know what c is. So that c there is going to be this c here, which is 12.80624. We leave that there. And now with this bit, you just want to be a bit careful. So you know that the distance from here to here is 10, because that's the base of this triangle. So essentially that bit there. So it's the base of the top triangle. And then this bit here is just going to be 12.806 minus 10, and that gives us 2.80624. And now I'm just going to add all the sides together. So that's going to be 10. .062 plus 2.8062. Add them all together and you get 41.6 millimeters. Moving on to question 6. Again, we have a right angle triangle. It's asking us to find the length BC. So if I label this, so this is going to be the opposite, that's the hypotenuse, and that is the adjacent. In this case, we know nothing about the hypotenuse, so we can ignore that. So we are then left with an O and an A, and that is tan theta is equal to opposite over adjacent. So we have tan 56 is equal to the opposite, which is BC over A, which is 12. So BC is going to be 12 times tan 56. And to one decimal place, that's going to be 17.8 centimeters. Well, the unit's already there, so we can leave that off. So we have PQR, which is a right angle triangle. Work out the size of angle marked X. So again, we can go in similar manner. So this is going to be the opposite. That's the hypotenuse, and that is the adjacent. Again, we don't know anything about the opposite, so we can ignore that. That leaves us with an A and a H. So that is going to be cos. So we have cos theta is equal to A over H. So we have cos X is equal to 15 over 18. So X is equal to the inverse cos 15 over 18. And to one decimal place, that's 33.6. Moving on to question 7. We have two liquids that are mixed together, A and B, to give you C. Now, with these type of questions, you want to draw out a table. So the formula, if we're going to use this density, is mass over volume. So you have three liquids, which is A, B, and C. And we have the mass, volume, and density. So we have the density of A is 1.8, density of B is 1.2, 80 centimeters cubed of A is mixed with 40 centimeters cubed of B to make 120 centimeters cubed of liquid C. Work out the density of liquid C. Now this is what we're trying to find. Now we can't just find this by adding the densities for A and B together, so bear that one in mind. So to work out the density of C, we are going to need the mass of C divided by the volume of C. Now we know what the volume is, it's 120, we have that here. We don't know what the mass is, so we want to work out the mass. We can do that by finding the mass of A and finding the mass of B. So the mass of A is going to be 1.8 times 80, which is volume times density, and that gives us 144. The mass of B is going to be 40 times 1.2, that gives us 48. And then the mass of C is going to be when you add them two together, so that's going to give us 144 plus 48, which is 192. So now we have the mass of C, and when we divide that, we end up with 1.6. Moving on to question 8. So we have group frequency table that gives us information about how long it took some people to solve a puzzle. Brian was asked to draw the cumulative frequency table for the information. This is the table that Brian drew. Write down one thing that is wrong with the cumulative frequency table. So all the frequencies in a cumulative frequency table should start at 0. So we can just write here that all intervals, intervals should start at 0. Question 9, we have a box plot. It's asking us to work out the interquartile range. The interquartile range is the upper quartile take away the lower quartile. What you want to be careful with here is each of these squares. So in this case, we have from here to here, we have 10 squares. That means each square is worth 4. And the reason I say that is because this one is right in between these two. So that's going to be 4 plus 4, which is 8, plus 2, which is 10. So this is going to be 50. And for the upper quartile, that's going to be 188 there. So we have 188 take away 50, which is 138 minutes. And Becky says 50% of the people waited for at least 2 hours. So if you look at the median is 120. So is she correct? Yes. And the reason is the median is 2 hours. The table gives some information about the length of time people waited on Tuesday. Now we know on Monday the median was 120. She was asked to compare the distribution of how long people waited on Monday versus Tuesday. People had to wait longer on Tuesday than Monday. Now one metric you'd use for comparison would be the median, because the median is the average of all the data. Give one reason why Becky may be wrong. So the median, she's saying they had to wait longer on Tuesday. So you can say that the median for Tuesday, brackets, which is 100, is lower than median on Monday. To question 10, we've got 2 people who invest X pound. So this basically means they both invested the exact same amount. And at the end of 3 years, Lewis's investment is that much. Work out the value of Sadiq's investment at the end of 3 years. So since they both started with the same money at the start, we want to work out what that original amount was. So in this case, we know Lewis went with better investments. Uh, 2.5% per annum, percentages out of 100. We add 2.5 to that. That gives us 102.5%. And as a decimal, that's going to be 1.025. Just to get that out of the way. So our formula looks something like he invested X pounds times 1.025 over 3 years, and that ended up with 344,605 pounds. So X is the amount you started with. It's going to be 344,605 divided by 1.025 cubed, and that gives us X as 320,000. So now we know what amount he started with, and we know that Sadiq also started with the same amount. So if you move over to the right hand side, so we know for the first 2 years, so as a decimal that's going to be 1.02, and as a decimal that's going to be 1.035. So in this case, he started off with 320,000, times that by 1.02 for 2 years, and that gives us 332,928. And then for the next year, 332,928 times that by 1.035, and that gives us 344,580. and 48 pence. Question 11, here's a sketch of a line. So we have 2 points. The point R is such that PQR is a straight line 2 to 3. Find the coordinates of R. So with this question, we are going 6 this way, and then we are going 3 up. So we know the ratio is 2 to 3. So we can multiply that by 1.5. So that means to go from here to here. If that was 6, this is going to be 6 times 1.5, which is 9. And in this case, if that's 3, this is going to be 3 times 1.5, which is 4.5. So the actual coordinate for x is going to be that one there, which is 9. And for y, it's going to be 4.5 plus the 3, so that's going to be 7.5. So the coordinate x is 9 and y is 7.5. So for the next bit, it's saying find the equation of the line that is perpendicular. Okay, so first we should find the equation of the line L. So we know that y is equal to mx plus c. We know that the intercept, that one there, is 3 because the line crosses the y-axis at 3. We now want the gradient, so we know we go 3 across, 3 up, so the gradient is going to be a half. So we have y, equation of line L is equal to a half x plus 3. And now they want the equation of the perpendicular line. Now to find the gradient of a line that's perpendicular, we do the gradient of line L times the gradient of the perpendicular line will equal -1. So the gradient of line L is a half times the gradient of the perpendicular line is equal to -1. So that means the gradient of the perpendicular line is going to be -2. And it passes through Q. So we still know that it passes through the same y-intercept. So the formula is going to be y is equal to -2x plus 3. Moving on to question 12. So with these, I like to expand them from left to right. So if you focus on the left 2 brackets first, so that's going to be that times that, which is 3x squared plus 6x minus 6x minus 4. And that is 2x plus 3 there. You can see that them two cancel out, leaving us with just that. So that is going to become 9x cubed. Oh, I think I have made a mistake here. So that is going to be x. So 3x squared plus 2x minus 6x. There we go. That was my mistake. Minus 4. 2x plus 3. And now we're going to expand from left to right. So that's going to be 6x cubed plus 9x squared plus 4x squared plus 6x minus 12x squared minus 18x minus 8x minus 12. And we can see these x squareds can be collected together. So that's going to give us 6x cubed plus x squared minus 20x minus 12. So question 13, there are 16 teachers. So we have 16 teachers, 120 girls and 100 boys. So work out all the different ways you can choose one teacher, one girl, one boy. So that's going to be 16 times 120 times 100. And that's going to be 192,000. Moving on to question 14. We've been asked to find SBA. So SBA, if I use a red color there, it's going to be that angle there. We've been told that BAD to BCD is 3 to 1. So if this is 3x, this is x. So using some circle theorems knowledge here, we know that opposite angles in a cyclical quadrilateral add up to 180. So that means 3x plus x is equal to 180, which means that 4x is equal to 180, which means that x is equal to 45. So you have this as 45. Now the question does ask for reasoning to state reasons. So this is going to be opposite angles in a cyclic quadrilateral add up to 180. So now that we have this angle, we can also notice the alternate segment theorem with this chord here. So we know that this angle here is going to be equal to this angle here. So if I just draw that one with a different color, this angle here is going to be equal to this angle here. So we can then say that SBD is equal to 45 degrees, and the reasoning is alternate segment theorem. And then we are left with SBA, which is what the question asks for. SBA is then going to be 45 minus 20, which is going to be 25 degrees. Question 15, we've been asked to find the length of BC. So the sine and cosine rule look like what we're going to have to use here. So if we just label my sides, that's B, and that's that. So it's asked me to find BC, which is essentially A. So we can use the cosine formula here. A squared is equal to B squared plus C squared minus 2BC cos A. So then we have A squared is equal to 8 squared plus 11 squared minus 2 times 8 times 11 times cos 72. And that gives us A squared is equal to 130.613009. And if I square root that, I get A as 11.4 centimeters. So part B is asking us to find the area of the triangle. So we're going to use the formula a half AB sine C, because we have two sides and an angle in between them. So we can do half times 8 times 11 times sine 72. And that gives us 41.8 centimeters squared. Question 16. So we've been given an iteration formula and it's asking us to find x1, x2, and x3. So we have been given x0 as 2. x1 is going to be the cube root of 10 minus 2 times 2 from there. And that gives us 1.817120.593. And x2, so that's going to be cube root of that, 10 minus 2, 1.817120.593 is equal to 1.853318.496. And for x3, we have the cube root again, so that'll be 10 minus 2 times the last answer, which is 1.853318.496. And that gives us 1.84626593. So moving on to the next question, it says the values of x1 and x2 found in part A are estimates to the solution of the equation in the form this. Okay, so what we've been working in question 1 with is a formula that looks like that. So that formula currently looks like x is equal to the cube root of 10 minus 2x. So that's what we've been working with so far, and that's what we try to find the estimate of. So if I just rearrange this, so if I cube each side, that's x cubed is equal to 10 minus 2x, and we have x cubed plus 2x minus 10 is equal to 0. So in this case, A is 2 and B is minus 10. 17, we've been given a histogram of some people that took part in the competition and their scores for the first round out of 40. 20% of the people got a high enough for them to qualify for the second round. Okay, look at an estimate for the score needed to qualify. We've been given the frequency density and the scores, so we can look at each section. So that is going to be A, B, C, D. So if we just write that here, A is going to be base times height, so that's 0.8 times 5, which is 4. B is going to be 1.6 times 10, which is 16. C is going to be 2.2 times 10, which is 22. And D is going to be 1.2 times 15, which is 18. If I add all of these together, I get 60. Now I need to find 20% of 60, so times that by 20, or 100, and that is 12. So I know this final square, adds up to 18. So these are people who would have got high enough. So we have a 12. So this will essentially be split in two. So we'll have a 12 at some point, and we'll have a 6 because those two add up to make 18. So if I do 12 out of 18 times that by 15, which is the width here, that means this represents 10. So it's going to be from here to here. And in terms of score, that's 30. So if you're given a sine graph here, use the estimates to find all four solutions of sine x is equal to 0.640 to 720. Notice this only goes to 60, but they want estimates for all four from 0 to 720. So 0.6 is going to be here. That's going to hit somewhere there. That's going to hit somewhere there. And that's going to come down. And of course, this is going to continue on down there. So let's just split these up. So that's 30, 60, 90, 120, 150. Okay, and each of these squares within goes up by 3. So six, sorry, not 3. Each of these squares goes up by 6. So the first one there is 36. That's that one there. The next one there is 144. Now, notice the next part where the curve goes up is here. So the first part was at 0. The next part is at 360. So we just want to add 360 to 36. That gives us 396. And we want to add 360 to 504. 114 to get 504. So write down an equation for the reflected version. So that's just going to be the negative version of the same graph. For the next one, we have f of x minus 2. So we're going to move to the right 2 times. So each coordinate, so if we start with that one there, move it to the right twice, that ends up there. That will end up there. This will end up there to the right twice, and that ends up there to the right twice. So essentially, we're moving each coordinate to the right twice. A, B, C are spheres, so the volume of A is the volume of B. So what you want to remember with this question is if you represent volume as x, it would be x cubed. The surface area would be x squared, and just a length or a radius would be x. Okay, you want to bear that in mind. So for A and B, we have the volume as 125 to 27. If we cube root these, we'll get the length, or we can call it the radius even, but if you cube root 125, you get 5. If you cube root 27, you get 3. And you'll see why we've done that in a second, because here they've given us the radius ratios. So they've told us B to C are 1 to 2, and these are all length or radius, so they represent x. So notice that they've both got B in them. Here B is 3, here it's 1. So I can multiply this by 3 and this by 3, and then that can be written as 3 to 6. So I can write the entire ratio of A to B to C as 5 to 3 to 6, and that is for length. But they want the ratio for the surface area, and like I said, surface area is squared, so that is going to be 5 squared, which is 25, to the ratio of 6 squared, which is 36 for C. So that is going to be 25 to 36. Moving on to question 20. So on a village, if it rains on one day, the probability that it will rain the next day is 0.8. So if I was to draw that out, so the probability that it rains today, and then if it rains on one day, so if it has rained today, the next day 0.8, so this probability that it won't rain is 0.2. And if it doesn't rain on one day, which is that case here, so the probability that it will rain the next day is 0.6. And this would be 0.4. The weather forecast say there's a 70% chance that it will rain on the village on Monday. So if you take this at 0.7, this would be 0.3. So that can be Monday. That can be Tuesday. Work out an estimate for the probability that it will rain in the village on Wednesday. So if it has rained, the probability that it will rain the next day is going to be 0.8 to 0.2. That's rain and no rain. And here it hasn't rained, so the probability that it will rain the next day is 0.6 to 0.4. It's rained, no rain. In this case, it has rained, so the probability that it'll rain again the next day is 0.8 to 0.2. And in the final case, it hasn't rained, so the probability that it'll rain the next day is 0.6 to 0.4. So rain and no rain. So essentially, we're interested in days it will rain. So that would be this one, this one, this one, this one. And if I just follow the tree diagram through, so that for the first case, it would be that. For the second case, it would be that. For the third case, it would be that. And for the final case, it would be that. So if you were to write this out, that would be 0.7 times 0.8 times 0.8, which is 0.448. This would be 0.7 times 0.2 times 0.6, which would be 0.084. This would be 0.3 times 0.6 times 0.8, which is 0.072. This would be 0.3 times 0.4 times 0.6, which is 0.072. And if you add all the probabilities together, you end up with 0.748. Question 21. So we've been given the formula of a pendulum, and it's asking us to find the lower bounds and the upper bound of g. So the first thing we should do is rearrange this equation to make g the subject. So at the minute we have t is equal to 2 pi square root L over g. I can move the 2 pi over by dividing each side. And now I can square each side to get rid of the square root. So that's just going to be t, and carefully with the square root, the whole thing is squared here. L over g. I want to make g the subject. What I can do here is use a nice little trick. I can inverse both sides. So I can get g on the top, on the right. So the way I do that is I flip the left, but I also flip the right. And now, notice what it's done. I can now make g the subject. G is equal to L times 2 pi over t squared. Right, so now we need to find the upper bound and the lower bound of g. So firstly, we've been given this to 3 significant figures. So that's 0.1 after the decimal place. And this has 2 decimal places, so that's 0.01. I can divide this by 2 to work out the interval, so that's going to be 0.05. And divide that by 2, and that's going to be 0.005. Okay, so for L, the upper bound is equal to 52.05, and the lower bound is equal to 51.95. All I've done there is I've taken away 52 from 0.05 and I've added it to it, and the same for t. So we have the upper, which is 1.455, and we have the lower bound as 1.445. And then to work out the g upper, it will be L upper, which is 52.05 times 2 pi over, and this is where it can get confusing. To work out g upper, we are going to use the upper bound of L, but we're going to use the lower bound of t because that will give us the highest value. So in order to make a fraction big, you make the denominator as small as you can. So in this case, that's going to be 1.445. And then to work out g lower, we are going to do the lower bound of L, but we're going to use now the upper bound of t. So that's 1.455. And we'll square that. And we're going to use 3.142 for pi and not the actual value of pi. And we get our answer to 984.37 and 969.02. That is the last question on the paper. I hope you found this video useful, and as usual, I'll catch you in the next one.